Boom! Yes folks, Hume here again. In this video we're going to do something different, something special. The content of this video is not something that is generally tested for exam purposes. So if you don't know it, it would necessarily hurt you in a mathematics exam. However, if you have any serious, deep, lingering curiosity about maths that goes beyond just passing an exam, then I would strongly suggest that you watch this video through, and I believe you will also enjoy it as well. In this video, what we will do, we will complete the square on the general quadratic, so that we will basically be moving from the standard form, just as we outlined in the very first video in the series on completing the square. We'll be moving from the standard form to the vertex form. So we will complete the square on this and get something that looks like this, and then we will find out what A is, what H is, and what K is. And at the end, we will have a particular discussion which you will see as we go along. So stay tuned and follow as we go. So we started. We know that if we have a quadratic where the coefficient of x squared is not equal to 1 or minus 1, that the very first thing we do is factorize the entire expression by taking out the coefficient of x squared as the common factor. So in that case, our first step here would be a, and we hit any square brackets here now, into x squared plus b over ax plus c over a. Alright? And then of course what we will do, we will perform the regular steps that we would have outlined previously on this particular quadratic equation. So we do the arithmetic manipulations inside here. We keep in this a outside, and then we will multiply the a back at the very end to get the final answer. So this will be a into, we're going now x plus, we're taking half the coefficient of x here, x plus b over 2a squared minus b over 2a squared plus c over a. So what we have just done is taken x squared plus b over ax and expressed it as x plus b over 2a squared minus b over 2a squared. And then we continue. So the next line will be a into square brackets again, x plus b over 2a squared minus, we work this out now, that will be b squared over 4a squared plus c over a. Alright? So just as we would have discussed in the videos prior to this, in the series on completing the square, when we have two entities here where one or both entities is a fraction, then what we do, we look for a common denominator across the two entities and express both entities as fractions with the same denominator. So that the next step, therefore, I'm going to change the color of the ink here now because we're going to rub off this and come back from the top. The next step, therefore, would be, let us see, the only sensible choice of denominator here would be 4a squared, right? So whatever we get, whatever we would do to this fraction to express it as a fraction with something over 4a squared, whatever we do to the denominator, we will also do to the numerator. So in other words, if you have a fraction and you multiply the numerator and the denominator by the same entity, it doesn't change the value of the fraction. 1 over half is the same thing as 2 over 4. That is what I get when I multiply the numerator and the denominator by 2. 1 over half is 50 over 100. If you multiply the numerator by 50, you get the 50. If you multiply the denominator by 50, 2 by 50 is 100. So when you multiply the top and the bottom in a fraction by the same entity, the value of the fraction doesn't change. So we could use that bit of knowledge to express this as follows. So you get a into brackets x plus b over 2a squared minus b squared over 4a squared. And I'm going to move this now for the sake of space and clarity. C over a is something over 4a squared. Good? So 4a squared divided by a will give us the entity that we have to multiply the top and the bottom here by to get something over 4a squared. So in other words, a multiplied by 4a will give you 4a squared. So that if we multiply a by 4a to get 4a squared, then we must also multiply c by 4a, which will then give us 4ac on the top there. And that is what we have going forward. Now, at this point, you have a minus sign in front here, and you have a positive sign in front here. So the easiest thing to do, there are other things you could do, which I wouldn't even try to go into now. The easiest thing to do is put the positive sign in front and put the negative sign behind. That way you remove all ambiguity as to what to do with the sign, etc., etc. Alright? So you go in again. So this is the same thing as a into x plus b over 2a squared plus 4ac over 4a squared minus b squared over 4a squared. And then we're going forward again, and we're saying that because we have the same denominator here, we could just perform the arithmetic on top at the level of the numerator. So that this will now be a on the outside by square brackets into x plus b over 2a squared plus, watch it now, 4ac minus b squared all over. Okay, I'll leave it like that. I'll leave it like that for the sake of argument. Right? Right. So we could do it like this. So in other words, we now have a singular entity that is of the form a into x plus h squared plus k, and I'll write that form just for the sake of clarity right next to it here. A into x plus h squared plus k. Remember, that is the form that we will be looking for. But look, we have it here. A. Well, no, we have one more thing to do. We have to multiply the a by everything inside there. So we're going to do that in the next step now, and then we will have the final answer. So just bear with me for our extra line, right? So we're going to change the color of the ink, and we're coming down in red now. So from here, we move to a into, well, we can remove these square brackets now, because this is the line where we will be multiplying the a on the outside by everything on the inside. So a multiplied by this would be a into x plus b over 2a squared, and a multiplied by this whole fraction here will be 4ac minus b squared over 4a. So now we could say, and we will move that there. Now we could say that we have this, and that this is of the form a into x plus h squared plus k. So you see, we get it back in the same corner where we had it at the start, just in a different color. So we would have taken the general quadratic ax squared plus bx plus c. We would have completed the square on that and gotten this fellow here, which therefore means that we could make the following equivalencies. Right? We could say that we could say now with absolute and total confidence, we could say that, well, the a and the a, it will be the same, right? This a will be the same as this a, so we can leave that alone. We can see that h is equal to b over 2a h share b over 2a. And we could say also that k is equal to 4ac minus b squared over 4a. This is also expressed in the form where, now if we divide, I'll just go to the arithmetic here. This is the same thing as 4ac over 4a minus b squared over 4a. So if we cancel out here, what you'll end up with will be c minus b squared over 4a. So k is expressed in this form. K could be expressed in this form, or it could be expressed in this form. Of course, there are other forms too, but those are the two main forms that people use. And why I'm going through all of this? Because what we now have here are the values of the expressions of the entities that people use when they take the formula approach to completing the square. Remember, at the very start of my series on completing these squares, 12 videos and all, in the very first video, I made the point explicitly that I was not going to go down the road of just giving people a formula and saying, well, h is equal to b over 2a and k is equal to c minus b squared over 4a. I'm not doing that, because we could do that, but you wouldn't understand what you're doing. And as much as possible, we're trying to avoid that situation where you're just doing something because you're told to do it and you don't understand what you're doing. Yes, especially at the lower levels, there will be times when you'll just have to accept something and run with it without knowing the proof or the demonstration, or without knowing why, or without understanding. So there is place in mathematics learning, especially in the early stages, for just accepting a formula and running with it. But what I try to do is, as much as possible, to explain stuff and break it down so that people could understand what they're doing. Right? And that is why in this case, where we're dealing with this particular topic of completing the square, I deliberately make a point of taking the long route, because that is the route that will encourage and facilitate better understanding. However, in this video, what we did is use the long method to derive the values for the short method. Just to make the point that even when you're using the short method, that it comes from somewhere. It originates from some place, a valid place. Right? So, for those of you who insist on using the formula, you would have seen how we derive the values here. Right? Of course, if you're using the formula, you don't necessarily need to know how we derive the values. But as I would have said at the beginning of this video, this is a very good exercise for those who have that curiosity, that interest in mathematics. And that is the curiosity and the interest that will take you to the higher levels of performance, right? That is the thing where you'll go beyond the call of duty, where you'll go beyond just the regular requirements for passing the exam, where you'll go the extra mile, and that will put you in a place, a good place mathematically. And of course, you know that going the extra mile is always a good habit, generally, to develop in any area in life. The second mile is where the magic is. Right? Remember that. So, I hope you would have enjoyed this video. And if you did, spread the word, stay in touch, look out for more. We have plenty more coming your way. Alright? So keep good, take care. See you in the next video.